Welcome to my talk, Spring Cloud on AWS, Amazon Web Services. We will discuss 30 minutes about how to run Spring Cloud applications on Amazon Web Services, especially using the Spring Cloud for AWS project, which is part of the Spring Cloud umbrella project. I'm going to walk you through how to basically design and run applications, or Spring applications in particular, on the AWS cloud. My name is Agim Emruli. I'm committer on the Spring Cloud for AWS project. I work heavily with AWS and Spring, obviously. And in my talk, I'm going to show how my experience is running AWS or applications on AWS. So Spring Cloud for AWS, this is a very, very short history, is part of the Spring Cloud project. I used to build that internally. It had been called Elastic Spring. It is now Spring Cloud for AWS, renamed to be part of the Spring Cloud umbrella. We are on the release train, so every time Spring Cloud there is a new release. There's also typically a new release for Spring Cloud for AWS. It's part of the umbrella. It reuses basically libraries of the Spring Cloud project. And the goal is basically to simplify or to springify the way how applications are written for the AWS stack. And the Amazon Web Service stack, most of the people try to think, what is Amazon Web Services? Well, Amazon Web Services is kind of infrastructure as a service, but it's to some degree also platform as a service. So infrastructure as a service is all what we know with the compute service. So EC2 or EC container service. So that's basically, give me an operation system and I can run my application. But Amazon Web Services is way more than that. It provides databases. So you can basically start up databases. You can start an Oracle, MySQL. They have own databases like DynamoDB, a document-oriented database. It provides a storage service, networking service. But on top, and this is where everything gets very interesting and appealing for Spring developers, they also have developer productivity-based services, for instance, application services. And this is the area where Spring Cloud for AWS is basically targeting, making it very simple to write application that leverage those services. So I'm not talking today only about the EC2 service at all. I'm talking how to reuse all those services in this stack or in this portfolio to write applications. And Spring Cloud for AWS is a framework which basically targets those services as we see here. So it's basically compute, database, storage. It is to some degree mobile services. It is application services. There is basically the focus and also management. And the idea and the vision of this framework is basically to write applications on AWS following every time the Spring triangle, the Spring philosophy. And Spring has every time one philosophy, and this is the simple object, as we know. The simple object is achieved by having dependency injection in place, aspect-oriented programming, and portable service abstractions. And if you write Amazon Web Services applications on AWS, it's quite nice. You have a very, very broad platform, but you will very soon recognize that those services are all API calls, and there is no real framework for that, or no real abstraction for that. And this is what we try, is basically to bring this Spring triangle into the hands of people who develop applications on AWS. And it all starts with dependency injection, for example. We all know dependency injection, we all love it. And the first thing what we do typically, whenever I run in the cloud, I need information about my environment. I need to know where I run. I need to know what instance probably I'm running. I need to know all the information of my environment. Amazon on EC2, so if I run my application, my Java application on EC2 container, there is different metadata I can use, basically. There is metadata of the instance, so which is basically automatically generated. There is metadata on tags. There's user metadata, so different types of metadata I can use. And those metadata can be injected. So this is a type of dependency injection. It's all known with the environment abstraction. So I can inject basically metadata into my application and use them and react based on that. The other thing is obviously injecting services. So whenever I run Amazon-based apps, I should typically use the services they provide. So it's not a good idea to install MySQL or Oracle on myself if I can use the RDS service, the relational database service, for instance. And those relational database services can be created on demand, so through a web UI. And the relational database service can also be consumed. And on dependency injection, what we do is basically don't use code or don't write code to retrieve the instance detail of your RDS instance, but use dependency injection. And this is what we do. For instance, there is support enable RDS instance, which basically fetches all the connection data, all the details of an RDS instance of a database that runs on AWS, creates a data source, and this data source can be used by the user. So for me, it does not make a difference for an application if it runs on AWS using RDS or if it runs locally using a local MySQL installation as an example. And this is the general idea of dependency injection of services. So don't retrieve the services manually by hand. Start to get them injected. It's the same like Cloud Foundry provides with the VCAP services variable. Here we basically try to inject those services into an application. The other thing is, if I run on AWS, those services might have special features which I'm probably not aware of if I'm running them on myself. For instance, the relational database service provides read-replicas. It's a typical scale-out pattern. So that means basically if I have a database, I can decide to scale it up. So I can start a small instance of a database with 1 GB of RAM, probably 1 TB of space. But if I now have too much pressure on my database, I can now decide to scale up or scale out. Scaling up on MySQL or Oracle, I can just increase the size of the instance, which is nice, but at some point of time I will also hit a natural barrier there. An instance cannot be infinite. It has some physical limits. And what Amazon provides is so-called read-replicas. That basically means I scale out my database. So that means I have one master instance in which I write to, and I can create multiple read-replicas, and I can use those read-replicas. If consistency is not the very, very critical, so for instance, if you have a data warehouse, if you have BI reporting, or some data which is not meant to be very critical between a read and a write, so the consistency, the asset consistency, then those read-replicas can be used to basically scale out my database. So I can do more reads on a database because I'm using read-replica instances. And this is something which can be done very transparent using Spring, working with Spring. That basically means my application connects to a master database to write, and this can't be changed. There is only one master instance where I can write, and this is the single source of truth. And there can be multiple read-replicas where I can read data from. And with Spring Cloud for AWS, for instance, there is a possibility that with the read-only flag, I can basically say in the method where I write data, the store method, this is a non-transactional method. There I have to go to the master database, like before. But when I read data, I can specify that this transaction is read-only. And what is then happening below is basically that the database call does not go to the master instance, it goes to the read-replica instance. Obviously, this has a huge impact on my application, because the data might not be up to date when I read, because there's every time a small gap between writing the data into the master instance and synchronizing them to the read-replica. But if consistency is, I can trade it to some degree, so I can relax my requirements on consistency, then a read-only database or read-replica really can help me to scale out my application. So this is for services which I can use, and there are different services on the Amazon platform for which there are standard abstractions, like JDBC. So the relational database service, there's only a difference to get the service instance, but there is no difference to use it. It's a common JDBC data source, and I can use it. But Spring provides also another thing, a portable service abstraction. So the portable service abstraction is basically interface to services for which there are no standard abstractions available, like JDBC, like JMS, and whatever. And the idea is to use those portable service abstractions in order to work with AWS services so that I can use Spring interfaces and work with them. Just a few examples where those services can be used. The first one is S3. S3 is a storage service, and if I write applications for the AWS platform, I should never write to the local file system, because typically the local file system is transient, so it might get deleted. Or I'm not sure if it's an EBS or if it's a read-only. So the general idea is if I use applications or write applications for the AWS cloud, I should use the S3 service. The S3 service is fast, it's durable, it's available. And with Spring Cloud for AWS, we extend Spring so that it understands a new protocol. So I'm not writing to file // I'm writing to S3 // I can specify buckets, I can specify files. And as we can see here on the download, I can read with the resource loader, and I can write also. There is a new writable resource which has been introduced in Spring 4.x, where I can also write data to Amazon S3. And as we can see here, the nice thing is I can use the same resource loader for which I can read files from a local file system in a non-AWS environment, and I can use the same resource loader to read and write from and to buckets. And this is what I should do, is basically based on the URL qualifier, I should basically flip between file and S3 to read and write files. The same happens for email. AWS supports an email service where you can send emails. You should use that email service. They have also an SMTP support, but the best way, in my opinion, is you use the Spring abstraction to send emails. There's a mail sender interface, and Spring comes out of the box with SMTP mail sender. If you use Spring Cloud for AWS, you don't need a Java XMail dependency. You can just send emails through HTTP, so there is no need to enable SMTP or to allow SMTP in your application. You can just send emails using the same abstractions you're used to send outside an AWS environment. The next thing is where here we can see on both examples, you have to code against those APIs. But Spring also provides very nice features like caching. And if you want to cache, or if you need to cache, what we have seen in the keynote, caching might make sense because you have an API throttling or something. Amazon Web Services allows to use a cache service. It's called Elasticache. And that cache is basically managed by Amazon Web Services. You can basically create it, start it. And there are two implementations available. There's a Redis cache or a memcache. Both has their advantages, disadvantages. So you have to find out which one suits your need better. So Redis or memcache. Memcache is for sure a bit more simplified, might be more efficient if I have less data. Redis might be more efficient if I have a lot of data that goes into the cache. And those cache abstraction can be used by Spring. With Spring Cloud for AWS, you, instead of enable cache, what is in Spring a standard annotation, there is a new annotation called enable Elasticache. And this Elasticache basically means please go and get the caching information. If it's a Redis or a memcache, set up the cache manager for me, and then I can cache. And as we can see, I have the same name, so I have a cache, a managed cache in Amazon Web Service called mycache, and now I have an add cacheable, and now I'm caching into a hosted service. I don't need to install memcache, Redis, or anything else. So this is really the beauty of the Spring abstractions, of the SPIs. We can hook in to those SPIs, and it doesn't matter if my cache is locally on a concurrent hash map, very simple, or it is really on a hosted Amazon managed cluster, a Redis or a memcache cluster. Amazon Web Services also provides services which are new in the sense that there is no equivalent in the local world. And one is, for example, the simple queuing service. It's a small queuing service. It's actually the first service that Amazon provided, so right before S3 when they started the Amazon Cloud. And it's an HTTP-based messaging service, so I can write messaging. It has the messaging semantics. It supports only string payloads, pay per message. So I pay a few cents per million messages. No transactions. So there's a huge difference between JMS-based messaging providers and non-JMS-based or SQS. It has visibility rules, which I can work to do semantics like how many times do I want to retrieve a message, how long should a message not be redelivered if it's not acknowledged. And this messaging service, there is a Spring messaging abstraction in Spring 4, and I can use this messaging abstraction to write messages to SQS. Also, again, the beauty of Spring. There's a unified interface where I can write messages to SQS and receive them. This is synchronous, so to speak, write and read. So I can convert and send. I can send any payload I want to send. And I can do a receive and convert. That means I pull the queue until I receive a message. This is OK for if I want to receive one message. But obviously, there is a need to receive asynchronously a lot of messages. And also for that, Spring has, with the messaging abstraction, there are message listeners. So there are message listener containers underneath. They pull the queue in a very efficient way. So they try to get batches out of messages. And I can receive that by just annotating my class or my method, to be more specific, with an add SQS listener annotation. I just put in the queue name. And then whenever a new message arrives, my method is called. The request is taken. It's deserialized into an object. So custom event is a domain class I've written on myself. And once I'm done, I can send a confirmation back. And with the add send to annotation, as we see here on the return type, I can just say, where does this result type go? So I can do some kind of request-reply implementations of message listeners. And this is quite familiar because there is, for instance, an add JMS listener annotation if I want to do that on JMS. And we have an add SQS listener annotation if I want to do that on SQS. There are no transactions on SQS, as I mentioned, but there is the possibility that I can acknowledge messages. So I can control when a message is deleted on the queue and when it's not deleted. So there are no rollbacks, but there is some kind of commit, which is an acknowledgement, which is what we support as well. So by default, every message is deleted out of a queue on SQS, but I can work in this manual acknowledgement mode. That basically means I acknowledge a message on myself. So I can do some business processing, and once I'm sure that this business processing is done, because I've written the message into a database or somewhere else, then I can acknowledge the message manually by myself. And this allows me to have some sort of transactional guarantees which I can use. The nice thing on SQS is I can not only consume my messages, I can also consume messages from different services. So that basically means I have different services on the Amazon platform. They write into an SQS queue. So for instance, if I upload a new file into Amazon S3, then a message is if an event is triggered, and this event is put into a message queue. And now I can start and react on that event. So whenever a new file is uploaded, I can do something in my application. I could write an audit log or whatever. Whenever CloudWatch fires an alarm, I can get a message and work on that alarm and do something on myself. So SQS is quite powerful, especially if integrated with other services. And we on Spring Cloud for AWS, we provide an abstraction to easily receive those messages. There's also a notification service. Notification service works differently. It does not have the messaging semantics. A notification service is I have one producer, he sends a notification, and a lot of people receive that. There is an HTTP-based notification model available. It's very scalable, so there's no polling involved compared to SQS, where we have to go to SQS and ask if there's a new message. We just register one time, we confirm our endpoint, and then by HTTP, our messages are all sent. And this is a very scalable service. We provide support to have the Spring MVC programming model. So I have an add notification message mapping that basically means whenever a new notification arrives, please call this method. There is a subscription mapping, this called once, that is basically for notification service to ensure that this subscription is valid. And then I can receive lots of notifications. There's obviously no guarantee that I will receive one. So if my endpoint is offline, notifications might be skipped after a certain timeout. But if I want to work on notifications, it's a very good way and a scalable way to work on an eventing-based system. So the next thing is, how do I deploy to CloudFormation? So we have seen there are a lot of nice services, but how do I deploy? Obviously, you could start to deploy manually, which is not a good idea, apparently. So I could configure each service manually by hand, then install my application on an EC2 instance. But the way how would I propose that is to use CloudFormation. CloudFormation is a deployment tool. So with CloudFormation, I can define in a template, I want 3 EC2 instances. Please install my application on top of that instance. I need an S3 bucket. I need 5 SQS queues. I need a database. And I just give this template to CloudFormation, and automatically all my platform is created, and I can use those services. What we have done in Spring Cloud for AWS with Spring Boot together, Spring Boot heavily relies on auto-configuration. So that basically means I put in a jar into my class path, which is called Spring Cloud AWS auto-configure. And with this jar file in my class path and Spring Boot as a container to run my application, I get all the services injected automatically, which are available in my stack. So I can write a definition, and I can say, well, I have 2 databases, I have 3 queues, I have a notification topic, and so on. And after starting my Spring Boot application on the EC2 instance, we provide all the services which are needed. So if I have a cache in my CloudFormation, I can automatically use the cache. There's no need for manual configuration anymore. And this is a real adaptive way to write applications. So I can just specify the stack I want to use, the services, and then I drop my application into AWS, and then automatically I can receive those services. With Spring Boot, we also moved forward. There are services like CloudWatch to have metrics. So I can put data into CloudWatch. I can put an alarm on those data, so whenever a threshold is met. And what we do, Spring Boot has an Actuator module, where I can also have data, but those data is locally. And what we have implemented, or what the combination what we have done is, you can basically use the Actuator for data locally. There are services, there's a counter service, for instance, and those data is then pushed into CloudWatch, so people can centralize, see the metrics. So here's an example. As we can see, you have a counter service, and those counter service provides you the possibility to increment and decrement data. That could be a business counter, so like how many orders did I receive, how many orders are open, how many orders are closed. Obviously, consistency is not guaranteed in this case, but to get a rough estimation how many orders I have or how many orders have been deleted. And this data is automatically pushed into CloudWatch, so there's no need for me to do anything. I can just locally increase the counters or decrease it, and then on CloudWatch I can see the graph, how is it going? So how my data is basically changing. I can create dashboards. I can collect all the data from multiple instances, do average or sums or whatever. And this is a nice way to combine the monitoring capabilities of Spring Boot together with the monitoring capabilities of the AWS platform. So this is for now. We are currently at the Brixton release. We're heavily working for a new version, and what I'm going to talk in the remaining 5 to 6 minutes is about the future. So where do we see our AWS applications evolving? And I want to stress 2 points. The first one is the API gateway, which is not so recent, but one of the latest editions of the AWS cloud. And then later about Lambdas, so how to write Lambdas in Spring applications. The API gateway is a central service where I can publish APIs and clients can retrieve those APIs and call them. What we want to do is working on a discovery client implementation, which Spring Cloud provides out of the box. There is a Netflix implementation for that. We want to write, or we are currently in the process of finalizing an API gateway-based implementation. So you have an application that publishes his API, his service to the API gateway, and then you have consumers who can basically receive those services or call those services through the API gateway. And the nice thing is, as we'll see with the Lambda, the API gateway can call a service which is running on my AWS cloud, or it can call a Lambda, for example. And all I need to do is I need to mark my application as a Spring Cloud application. This is a Spring Cloud annotation that is already available today. I start my application, and what we do then, we scan where do you have controllers in your application, and we publish those controller URLs to the API gateway of Amazon. So we parse that, the method, we parse the parameter types, we parse also, or we generate a JSON schema if needed, if there are complex types involved. And those APIs are now published on the API gateway. So those APIs can now be called by consumer applications. The interface information can be retrieved by the API gateway. So what methods, what resources do I have, what methods do I have on those resources? Those can be then retrieved by the API gateway. I can consume those methods with a REST client. And here I don't put a physical address anymore on the URL. I only put a logical name. This is known from Spring Cloud by Eureka or Zookeeper or Consul. And those logical name, my-service, is then resolved against the API gateway. The physical address is retrieved, and then the call is made to the real API gateway address, which is running my service. So this for the API gateway. Now we are moving forward. The API gateway supports two ways to call application. The first way is to call a normal application in the backend. The second way is, for instance, to use Lambdas. Lambdas is something AWS has introduced. Lambda is, you can think of, you write a function in Java, which is an implementation of an interface. You put in all your jar files into a big fat Uber jar, and then you deploy this jar file to AWS. You register the method, and then you don't take care about containers or servers anymore. It's what's called serverless architectures. So you only give Amazon this piece of code, and you say, please run it. And this code is run when a trigger is available. This is nice, but it's not so nice to implement interfaces from Amazon, which are very technically driven. What we want to do is we want to have a Spring, or we are currently in the process of finalizing that, to have a Spring-based Spring annotation, add Lambda function. In this class, you can use dependency injection and everything. So there's no need that you start a container and do all this stuff. You can really use all the power of Spring. And this Lambda function is called with the payload of the Lambda, and you can work and you can return something. And you are only billed for the time the Lambda runs. So this is a pricing model. So you don't pay anymore for a server that runs 24/7. You only pay for the method execution. So the minimum is 100 milliseconds, and you only pay for the time your method executes, and it's up to Amazon to do the scheduling, the load balancing, and so on, which is quite nice because you really don't have to think about servers anymore. Those Lambdas, we want to build very small apps. So that basically means you have an application. This application has a generic Lambda handler that receives the Lambda call, dispatches that to your Lambda function, or Spring-based Lambda function. Your Lambda function can use Spring Beans, like it wants, and this is deployed to AWS. And this Lambda function can be called by different triggers. So there's the trigger API gateway, so that means the Lambda function can be called through an HTTP request. It can be called by an IoT service, so whenever something happens on the IoT service, or it can be called by Kinesis from data streaming. This is the power, actually, of Lambdas. There are different triggers you can use to call your Lambdas. You don't need to take care about Tomcats or servers in general. You just deploy Lambdas, and those Lambdas are called automatically. We are heavily working on those features. If you are interested, after my talk, I have some demos. Unfortunately, my talk time is over now. If there is some interest, I have some demos already running, and we are planning for the next release, for the Camden release train, to have a first Lambda support implemented so that you can really run Spring applications as Lambda functions. All right, so thanks for listening to my talk. If you have any questions, there's still a break, so we have 10 to 20 minutes here in this room. So I'm happy to answer them here in front. Thank you very much.